Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about diffraction of X-rays, that is Bragg's Law. Bragg's Law. Diffraction of X-rays. What does it mean? Okay. Consider a crystal as made out of parallel planes of icons. Consider a crystal are made up of parallel planes of icons spaced a distance d apart. Okay, parallel planes had a distance a d apart. Excuse me. The condition for a spark peak in the intensity of the scattered radiations are there should for having a sharp peak intensity of X-rays, we have two conditions. Okay, that the X-rays should be securely reflected by the ions in any one plane. Okay, the X-rays should be securely reflected by the ions in any one plane. We have placing two parallel planes, right? For while placing two parallel planes, the X-rays should securely reflect. Okay, while it is passing from this side, it should be reflect on the other edge, reflect by the ions in any one of the plane. That the reflected rays from successive plane should interfere constructively. We have two planes. Okay, we have two planes parallelly placed. Once when the X-rays are passing, we have two conditions to have a very sharp peak in the intensity of scattered radiation. To find the sharp radiation, we have parallel planes placed. While the rays are passed from one plane, okay, it is securely reflected by the ions in one plane, and this reflected, this when we are going to pass, it will be reflected outside, and this reflected rays will that reflected rays from successive path, from this path should interfere in this another parallel plane constructively. Path difference between two rays reflected from adjoining planes, we have an angle of 2d sin theta. These two parallel planes, right? It cannot be as such straight as I showed. It will be light tilted area. It will have an angle of 2d sin theta. Okay, we have two parallel planes. It should have a constructive and successive reflections in both the sides. Okay, it will be in an angle of 2d sin theta. For the rays to interfere constructively, this path difference must be an integral number of a wavelength. Okay, this path, right? This path length should be the path wavelength should be of integral number of wavelength lambda. Generally, we used to measure the wavelength by lambda, right? N lambda is equal to 2d sin theta. Okay, as in this diagram we can see that we are placing two parallel planes, right? Once the rays are passing, constructive interference, when it is passing, we are going to find d sin theta in the other end, right? From d sin theta we are going to pass the X-rays, and at the 2 theta angle, right, in that place we are going to measure the X-ray. Okay, Bragg's angle is just the half of the total angle by which the incident beam is deflected. Okay, deflection, we are going to find in this slide we are going to in this video we are seeing about diffraction of X-rays, Bragg's law, right? Bragg's angle, that angle is, right, the angle 2d sin theta, that is called Bragg's angle. N lambda is equal to 2d sin theta. Bragg's angle is just the half of the total angle by which the incident beam is deflected. How much the incident beam is deflected, it is this Bragg's angle is just half of the total angle. It is not the full incident beam passing. It is just half of the total angle which is passing. Okay. N lambda, Bragg's equation is N lambda is equal to 2d sin theta. Thank you.